Students, welcome to my YouTube channel. In this video lecture, I am going to answer questions from sample paper number 1 from the 4th edition RK Bali navigation book. Now, if you have any other edition book like the 5th one, the 6th one, the 7th one, no problem. The questions in those books, in those edition books are also the same as the questions in this book. So now let's start. An artificial horizon has 2 degrees freedom vertical spin axis, 2 degrees freedom longitudinal spin axis, 2 degrees freedom and a lateral spin axis. So correct answer is 2 degrees freedom and vertical spin axis. Next, question number 72. A turn indicator used in conjunction with an attitude indicator will indicate what? So a turn indicator will definitely show a turn direction. So this is your turn indicator correction. So this is the inclinometer, and in this inclinometer you have a ball in the center which indicates a coordinated turn. Then you have this markings. You have a miniature aircraft. Now when this miniature aircraft is like this, let's say it's a left hand turn. So miniature aircraft right wing will go down, the left wing will go up. Now when it is aligned with this mark, that means it is performing a or executing a 3 degree per second rate 1 turn. Correct? So a turn indicator used with artificial in the attitude indicator shows a turn direction. Now looking at this, you can say that aircraft is turning right. Similarly, in an artificial horizon, the miniature aircraft will turn to the right hand side. Rate of turn, yes. Looking at this, you can tell that aircraft is performing a standard rate turn of 3 degree per second. Correct? So, option Bravo is eliminated. Angular velocity about the true vertical axis, angular velocity about aircraft vertical axis, angular velocity about longitudinal axis. So, correct answer is option 4. So, option Charlie is the correct answer. Statements 1, 2 and 4 are the right ones. Question 73. Rate of turn indications are proportional to TAS, true airspeed, proportional to calibrated airspeed, proportional to mass. Now always remember rate of turn indications are proportional to this true airspeed. Now if your true airspeed, your true airspeed is too low, you're flying at a too low true airspeed and you're trying to turn your aircraft left or right, let's say, in that case, you will be slipping. You will not perform a coordinated turn, you will perform an uncoordinated turn, such as slipping one. If you're flying at too high or too fast a true airspeed, you will be flying an uncoordinated flight called skidding. Okay, so rate of turn indications are proportional to true airspeed. Okay, so if you're flying at very fast true airspeed, so you will get thrown out of the turn. You will get thrown. Let's say this is the center of your aircraft. This is the center of the circle, and you want to make a right-hand turn. So if you're flying at too high true airspeed, your aircraft will be thrown out of the turn like this. It will be thrown out of the turn. It will not be able to perform a right-hand turn. Why? The forward speed of your aircraft is very fast. Okay, and angle of bank of your aircraft is too small for the speed that you're flying at. So the solution, this is called skidding. You're flying away from the center of the turn. So the solution to the skidding is reduce your true airspeed, decrease it, and increase the angle of bank of your aircraft. If you don't want to decrease the true airspeed, the only solution left is increase the angle of bank of your aircraft. So that will compensate for this maximum or this fast true airspeed, and you will be able to turn your aircraft inward. Okay. Slipping happens when you want to turn your aircraft to the right hand side, let's say, and you are able to turn your aircraft to the right hand side, but only that your aircraft is falling inside the turn. It's falling inside the turn. Now this happens when you are flying at a too low true airspeed. The speed available is insufficient to perform a coordinated turn along the circumference of the circle. Okay, So you are falling inside the circle. You are falling actually because speed is slow. So lift component is slow. So therefore the solution is increase the speed of your aircraft so that aircraft stabilizes itself and decrease the angle of bank. Slipping happens when you have banked your aircraft excessively. Okay, next. Question 74. For a rate 1 turn that means you are turning 3 degrees every second at 150 knots, the angle of bank must be what? So the formula is angle of bank equals to true airspeed divided by 10 plus 7. So speed is 150 knots divided by 10 plus 7. So angle of bank equals to 15 plus 7, that is 22. That is 22. Following a left engine failure, the pilot of a multi-engine aircraft uses rudder to arrest the yaw while side slipping down track with the wings held level by ailerons. What will the turn and slip indicator show in this condition? Now, let's say this is your aircraft. Okay, this is your aircraft. It's a multi-engine aircraft. That means it's twin engine 1 and 2. Okay, you're flying straight ahead. Now all of a sudden the left engine fails. When the left engine fails, that means the left engine is unavailable. What will happen? Only the right engine will be producing a thrust in the forward direction. The left engine is failed, that means no thrust, only drag. Only and only drag. Now wherever drag exists, that direction or on that side, your aircraft will yaw. So if there is drag on this side, aircraft as a result of which aircraft will immediately start yawing to the left hand side like this. And this thrust that is generated in this direction, it will propel or force the aircraft or make the situation even worse, yawing your aircraft to the left hand side and at the same time banking your aircraft to the left hand side. So this happens, everything happens all of a sudden, very suddenly, and you do not have much of a response time. So the immediate reaction or the immediate solution to such an undesirable situation is that you immediately bank your aircraft to the right hand side. Okay, the problem is your aircraft will start yawing and banking to the left hand side. So the solution is the exact opposite. Bank your aircraft extreme bank, excessive bank to the right hand side. Okay, excessive bank right. So that use trim to relieve excess pressure. Okay, or you can use trim and aileron trim, and after that you can use your rudders to maintain directional control. Okay, to maintain directional control. Now here it's stated explicitly that wings are held level. So if wings are held level, that means the turn coordinator the turn coordinator miniature aircraft will also remain level because wings are level, right? So So that means needle will remain in the center like this, the miniature aircraft needle right, needle left. So the correct answer is option alpha. Since wings are held level, the needle will also remain in the center position. Next is you are using rudder to arrest the yaw. So the yawing tendency will be towards the left hand side. You are going to use the opposite rudder to arrest that to prevent that from happening. And you will use that much rudder that is required to keep your flight in a coordinated flight condition as much as possible in the center position. Okay, so both needle and ball will remain in the central position. Next, in a satellite assisted nav system, a fix is obtained by aircraft's receiver measuring the phase angle of signals received from a number of satellites in known positions, measuring the time taken for aircraft transmissions to travel to satellites and return to aircraft, measuring the time taken for a minimum number of satellites transmissions in known positions to reach aircraft receiver. So correct answer is option Charlie. The time taken for minimum number of 6 satellites transmissions to reach aircraft receiver. Next. An airway which is 10 nautical mile wide is to be defined by two VORs, such as each having a bearing accuracy of plus or minus 3.5. In order to ensure accurate track guidance within the limits of the airway, the maximum distance apart for the VORs is approximately how much? So let's say this is one VOR transmitter. This is the second one. We have to find out the maximum difference between them. So first, and so this is the airway joining these two VOR1, VOR2. Now this accuracy of this airway is 10 nautical mile wide. So that means 5 nautical miles on either side. This road, this radial or this airway is nothing but a road in the atmosphere. It's uh, it is 10 nautical mile wide, meaning 5 nautical mile on each side. Next, the bearing accuracy is plus or minus 3.5 degree. So bearing accuracy is plus or minus 3.5 degree. Okay. So now we have a triangle in front of us. We have a triangle in front of us. We can, so let's join this. We will find this vertical distance. This distance will be equal to this distance and then add both of them and you get the space between these two VORs. So 3.5 degree error angle accuracy limit 5 nautical mile each side. So this will be 5, this will be 5 and this will be also 5. So 5, 3.5. We have to find this the measurement of this side. So we can use 1 in 60 rule. Let's use that. So it states that track error angle equals to distance of track multiplied by 60 divided by distance gone. Okay, so distance of track is 5, distance gone unknown multiplied by 60, angle 3.5. So x equals to 5 multiplied by 60 divided by 3.5. So 5 into 60 divided by 3.5 is 85.7 or approximately 86 nautical mile. So if this is 86, this will also be equal to 86. So the total distance between these two VORs is 86 multiplied by 2, approximately 172 nautical miles. So the closest answer here is Bravo, 165 nautical miles. Let's use tan theta formula and find out the distance. Tan 3.5 degree equals to opposite upon adjacent. So 5 divided by x. So x equals to 5 divided by tan 3.5, which is 0.06. So 5 divided by 0.06 is 83.3. Okay, with the 1 in 60 rule formula, we have got 86. Using tan, we have got 83.3, so approximately 83. So if we go by this formula, the total distance between these two VORs will be equal to 83, 83, 83. So 83 multiplied by 2, that is 2 8s are 16, 166. So that's why option Bravo. Okay, so do find out the answers using both ways and see and then check the closest option. 78. A DME in tracking mode is subsequently experiencing a reduction in signal strength. This will switch the equipment in the first instance, okay, in the first option, in the first choice, to what kind of mode? Standby mode, signal controlled search mode, memory mode. So a DME is in tracking mode. Tracking mode means the DME in your aircraft is successfully locked in with the DME ground station and it is successfully getting all the information like ground speeds, land trains, etc. but all of a sudden it has lost signal or it has lost contact with the ground station. So when this happens, the DME in your on board your aircraft will automatically switch to memory mode. It will automatically switch to memory mode. When it switches to memory mode, it continues indicating the previous slant range. Okay, the slant range which you were getting or which you were getting indicated just before this loss of signal strength happened. That indication or that slant range, that previous slant range, will continue to be shown to you for at least 10 seconds. Okay, and in this 10 seconds, while the system is in memory mode, it will try to achieve a lock on with the DME transponder on the ground again. If this uh, if this uh, if this trial or this attempt to achieve a lock on again with the ground station doesn't happen or doesn't happen successfully, then the DME in the second chance or in the second instance go back to search mode. In the search mode, it will start searching for favorable DME ground stations, and with whichever DME ground station it achieves a lock on, it will start tracking with respect to that DME ground station. Okay, so remember in the first instance, it will switch to memory mode for 10-30 seconds. And if that fails, if that doesn't, if the DME station is not able to achieve a lock on in that time gap, so it will switch to in the second instance it will switch to search mode. In which situation will speed indications on an airborne DME most closely represent the ground speed of an aircraft flying at flight level 400? So ground speed indications are correct only and only when you are tracking only and only when you are tracking towards the DME station, directly towards the DME station, okay, or directly away from the DME station, towards the station or away from the station. Okay, what happens? The DME indicates slant range of your aircraft. Slant range of your aircraft. So this is slant range number one. Now after that, so this is slant range number one at this position. When you fly from this position and move closer to the DME station, the slant range will change. Okay, so how fast you are moving towards the DME station determines how fast this rate of change of slant distance will happen. This rate of change in distance coupled with time, how much time is required for the radar signals to go to the DME station and come back to your aircraft. So this distance and time is used to calculate speed because we all know speed equals to distance by time. So using this formula, ground speed is calculated. Now, ground speed is most accurate when aircraft is either flying towards the station or away from the station, because only in these two choices or in these two situations, the slant range between your aircraft and the any station will change. The rate, the distance will change. So, with that change in distance, we can calculate or evaluate the rate at which that change is happening. If aircraft is flying parallel to the DME station, there is no actual change in the distance between your aircraft and the DME station that is taking place. No change is taking place. You are at a constant distance from that DME station. But if you are flying towards the station or away from it, the distance between you will continuously change. So that is one condition, you should be flying towards or away from the DME station. The second condition to obtain an accurate ground speed is that your aircraft must be as far as possible the DME ground station. Okay, as far as possible from the DME ground station. So the correct answer here is when tracking directly away from the station at 10 miles. Okay, you must track away from the station. That is the criterion number one is satisfied. When tracking directly towards the station, yes, criterion one satisfied. Then passing abeam the station, parallel to the station, no. So now let's check the second part of these options. 10 miles and 100 miles. So 100 nautical miles is more than 10 nautical miles. So this second part satisfies option 2 as well, the criterion number 2. Your aircraft must be as far as possible from the station. So the correct answer here is option Bravo. Which of the following is an ILS localizer frequency? So ILS localizer operates in the VHF band starting from 108 megahertz, ending on 112 megahertz. More accurately, actually 11.9 megahertz. So in this frequency band, it will operate in this frequency band, and all frequencies with odd decimals like zero point 0.9, zero point 0.3, zero point 0.5, like that. All frequencies in falling in this frequency band with odd decimals belong to ILS localizer. Other frequencies falling in this frequency band with even decimals belong to VOR. Even decimals belong to VOR. So correct answer here is 109.15, 108.25, 110.20. So all these three frequencies fall in this frequency band. Yes. Now the second criterion is odd decimals. Point 0.1 is odd, point 0.2 is even, point 0.2 is even. So the correct answer is option A. For ILS localizer, we want odd decimals, so option A. This brings the curtain down on this video lecture. I hope you have all enjoyed this video lecture. You have learned something new and you have understood the teaching that I have done in this video lecture. Practice these questions again without looking, and set a timer also. So that will give you an idea how much time you are taking to understand the question, do mental calculations, and answer the question. All the best. In my next lecture, I will solve the next remaining questions. So do watch that lecture.